Multiple Probe Tools, MPT Interpretation Workflow. In highly deviated and horizontal wells, segregation between the different phases is likely to occur. Here are the holdup and velocity image views obtained using distributed probe measurements. The cross-section reveals that the flow is stratified, with the lighter phase flowing faster towards the top of the tubing. By displaying the location of the centralized density and velocity measurements in the cross-section, it is clear that these are not measuring representative cross-sectional velocities or holdups, which are necessary for conventional multi-phase profiling using correlations. In these situations, it is necessary to consider the actual velocity and holdup distributions for each cross-section of the well. This is the domain of the Multiple Probe Tools, or MPT. In this video, the main steps of the MPT interpretation workflow will be summarized. Compared to conventional PL, MPT datasets contain a large number of mnemonics for the various holdups and spinner measurements. Emeraude incorporates built-in templates to display the data in specific layouts, facilitating quality control. Open the Spinner View template. This array tool contains 5 spinners, which are vertically distributed along the cross-section. Now call the electrical probes. At this stage, it might be necessary to apply editing options such as filtering or hiding. From the Edit QA/QC tab, activate the specific measurement using the Pick Nearest option. All the possible editing options for that measurement will be enabled. Specific editing can be applied to different sensors and passes by selecting the nodes. A very practical way to display the MPT data is through image views. Call the specific template and generate an image view for each pass. For this particular tool vendor, the image view displays the measurements vertically in the cross-section. Oil-water stratification is identified. Right-click on the image view and select Cross-Section. It is possible to scroll along the image and see how the holdup distribution changes with depth. In this case, the fluid velocity is also displayed by yellow points. Create a new interpretation. The type is classical and the method is zoned, with loose slippage compliance, as the slippage between phases will be obtained directly by the MPT sensors. Go to the Spinners tab. A holdup weighted spinner calibration option is available, which improves the accuracy of the apparent velocity estimation for scenarios such as tool rotation or changing holdup distribution with depth. In this case, use the traditional individual spinner calibration. Click on Reference Channels. For MPT interpretations at this stage, it is necessary to define only temperature and pressure, since the other inputs will be generated through the MPT processing. Display the spinners. As in conventional PL, it is necessary to obtain the apparent velocity for each spinner, for which it is necessary to specify the calibration parameters. Since there are only 2 passes, use constant calibration slopes and thresholds. A template facilitates the display of these new tracks. Use the default PVT definition, including water. Note that since the rates are computed at downhole conditions directly by the measurements, the PVT is used just to compute the surface rates. Click on MPT. Select the sensors to be used for the processing. For example, in this case, as there is no gas in the logged interval, remove the optical probes. Different interpretation algorithms for velocity and holdup data are available to obtain a continuous function from discrete points. Constraints can be applied to the interpolation algorithm. In this case, as seen in the image views, set the gas holdup equal to 0 and force stratification. When multiple passes are present, it is possible to process them in combine mode, where the n passes are stacked together and the data is treated as coming from a tool of n times the original number of sensors. MPT processing will generate at every depth a single average rate and holdup value of all present phases at downhole conditions. When the MPT processing is completed, the outputs are now reference channels of the interpretation. Next, define the rate calculation zones. In this case, since this is an open hole completion, these are selected manually based on the intervals of constant rate. Click on Rates. The flow model can be restricted to water hydrocarbon. No need to select a specific correlation, since the match is directly on rates, negating the need for slippage models. Click OK. The flow profile is obtained based on the match of the model with the MPT outputs. In this case, as some inflow zones are producing and injecting simultaneously, it is necessary to apply a global improve. The final profile shows all the contributions with the same sign. Well views can also be treated in order to display the effect of the well deviation on the holdup distribution. This video has shown a generic MPT interpretation. Tools from different vendors may require slightly different processing, which may include holdup computation. Specific videos are available on our website. Click on Settings, Multiple Probe Tools. It can be seen that Emeraude contains all the MPT tools from all major vendors in the market. However, if a tool geometry is modified or a new tool is developed, it is easy to define it and use it as with any other built-in tool. For example, creating a copy of the Fast Spin tool it is possible to add a second circumference and redefine the mnemonics of the various sensors. This concludes this video on the MPT interpretation workflow.